We get like Morgan Freeman to narrate it for us.
Great. David Attenborough's.
There you go.
Hi, I'm Hillary Sorensen. I'm the Water Resources Extension Educator with Minnesota Sea Grant. Welcome to the first training for the Minnesota Lake Lookout Project.
And hi, I'm Chris Philstrup. I am a lake and stream scientist with the University of Minnesota's Natural Resources Research Institute, based here in Duluth, Minnesota.
And today we are going to talk about collecting a water sample, particularly focused on measuring chloride or the salinity in your lake. We're going to talk a little bit generally about the project, what we're all doing here today. When you're out sampling, you will not be on a frozen lake, so you can just ignore the rest of this. But this project is called Minnesota Lake Lookout, and the goal is to build a network of volunteer monitors to track 2 water quality problems that we have in Minnesota lakes. The first one is chloride pollution. This is typically from the use of road salts in the winter months and also water softeners. And the second problem is harmful algal blooms. Today we're not going to focus on algal blooms, we are just going to focus on chloride. And so, Chris, do you want to tell a little bit about why we care about chloride in lakes?
Yeah, so why we care about chloride is that we have these really great freshwater resources in the state of Minnesota. Let's keep our freshwater lakes fresh, right? Let's not make them salty. So the problem with chloride and other salts like that is organisms have different tolerances for the levels of salt in the water. So if there's too much salinity, that can harm the organisms. But one of the other really interesting things about salt is it's really dense, right? Salt water is dense and it sinks. So if we have too much salt going into our lakes, we could actually get to the point where our lakes stop mixing when they're supposed to mix from top to bottom. And when you change the physics of the lake, that has profound impacts on the biology and chemistry of the lake as well, and can contribute to other water quality issues that we're faced with in the state of Minnesota.
The other thing I'll add about chloride pollution is that once it enters a lake, it doesn't break down naturally, so it just stays there. And even a small amount of chloride can contaminate a freshwater ecosystem, so it doesn't take much. The other thing about the 2 water quality problems, and the reason that we want to engage volunteers, is that both HABs and chloride influxes are unpredictable and they're episodic. So we don't know when or where there is going to be a runoff event that brings chloride into a lake, and we don't know when or where an algal bloom might pop up or if it's producing toxins. So the power of people, of getting volunteers out on lakes, particularly in rural areas where researchers and state agencies don't have the capacity to get out to sample every time something happens, that's really the goal of building this network, so that we have a better understanding of these 2 problems, when and where they're happening, and that will help us direct resources to help tackle these. Okay, so let's get started. In your sampling kit, you will find a series of items that we will need for today. One of the most important is going to be our data sheet. You will find a clipboard with a data sheet. We will walk through this later, as well as a pencil. Pencils are better than using pens because if a pen gets wet or the ink gets wet, it will run. So pencil is always the best to use in the field if possible. Your data sheets will also be on Write in the Rain paper. So if they do get a little bit wet, no problem. You'll also find this pen style water quality meter. This is how we're going to be able to measure the salinity concentration in your water sample, and this will also take a surface temperature reading. You will also find some water sample bottles. We are going to walk through exactly how to do these to collect your sample in just a bit. Your kits will all come in a cooler. This is where you'll find everything that you need to collect your water samples, and we will go through step by step how to use all of this. One of the first things to think about when you're going to go out to do some water sampling is safety. So a few things to keep in mind. The first one is just to check the weather conditions before you head out. The second is if you are in a boat or really by the water, you should have a PFD, a personal flotation device. This can be a life jacket. You don't have to wear them all the time, but they should be with you. And children do need to wear their PFDs at all times. Never go out sampling by yourself.
There you go. And when you're going to collect a sample, it's always good to remember your footing. And if you're walking on slippery surfaces, just take extra caution. When you're collecting a water sample, if you happen to be reaching over a boat or reaching over a dock, just make sure that you're not putting all your weight out into the water and you tumble in. And finally, if you're collecting samples and you notice like a green surface scum on the surface of the lake, that could be a cyanobacteria bloom. Wear the provided gloves just to make sure you don't come in contact with those blooms. Always after sampling, please wash your hands when you go inside to remove any residue that may be on them as well. And if you're sampling and you start feeling a little bit lightheaded in a cyanobacteria bloom, please move away from the area and just get fresh air. So with each kit, you'll also have a data sheet, and it's really important to fill out this data sheet so we can accurately record what your readings are. Right now, we're just going to walk through some of the notes we're going to take on what the sample location is, where you're located, and also what the conditions look like. So the first one is lake name. So here I'm currently at Pike Lake in Duluth, Minnesota, so I would write Pike Lake down. Location description, we are in the middle of the lake on about 28 inches of ice. So I might write something like that down. You can get GPS coordinates from your phone if you open like Google Maps or Apple Maps or something like that. You can record the lat and long. And then we also just want you to get a general idea, record what the environmental conditions look like, such as weather. So today we are outside and it is clear, it is sunny, I am squinting, it's a beautiful winter day here in Minnesota. So I would check that it's clear and sunny. If it was partly cloudy, you could do that, or overcast. It's really important to note if it's like raining or snowing at the time. We don't have any of that. And then there's also a category for, has there been precipitation within the past 24 hours? And luckily we have not had any precipitation within the past 24 hours. But if there's a big rain event that precedes you going out into the lake to collect a sample, we really want to know that information. And so with the precipitation, you can say whether there's none, it's light, moderate, or heavy, such as a big storm event. And I would also look at my favorite weather app on my phone to record what the air temperature is. Right now it's about 14 degrees Fahrenheit, so I would also add that to our data sheet. If you also notice anything unusual about your sampling location, let's say there is a harmful algal bloom, we do want you to note that. Today, I would say there's ice in the middle of my sampling location, so that's something I would want to note. So just any notes that you think are important that will help us try to better figure out what's going on with the data you're collecting, that would be great.
All right, so now we are going to take a salinity reading of your local surface water. So first, this is a pen style water quality meter. These will already be set up, so all you have to do is push the button at the top to turn the meter on. I can do that through gloves. At the top of your screen, you will see the word salt along with the battery level. So right now this is fully charged and I am seeing salt at the top here. So I know it's about to measure the right thing. And the units on this are a little bit different than what is in your data sheet. This is gonna say ppm below the reading. What your data sheet says is milligrams per liter. They're the same. So you can write down the number that you read off of your meter. And then at the bottom of the screen is gonna be the temperature. So in order to take your reading, all you do is remove the cap, not featured here today, but when you have your meter, there will be a loop that you can put around your wrist. You want to make sure to not drop the meter in the water when you're taking your reading. So all you do is submerge the tip of the meter up to this submersion line, and you want to hold it steady until the reading stabilizes. So I'm actually going to twist around to look to see when this holds still. Okay, it is stabilized at 178, and you'll call that out to your field partner who will write it down on the data sheet.
178.
And I will also let you know the water temperature. It is 32 degrees Fahrenheit.
32 degrees Fahrenheit.
And it is a good idea to have the person writing down the data repeat it back to you just to make sure that everybody's on the same page. Then you can recap it and you're done.
Sweet. So before you collect your sample, your amber bottle will have a sample label placed on it, and all you need to do is simply fill that out. So what I would do today is I would put the date, the time of sample collection, which is 10:15. My location is Pike Lake. And also, it's always good to write your initials as the sampler. So right here, I would write CTF. So before we collect our sample, we want to triple rinse the bottle. The reason we do this is we just want to remove any kind of residue that may be left in the bottle before we collect the actual sample that we want to analyze. So the way we do that is we just invert our bottle, turn it right side up to collect a sample. That's rinse 1. Do it again. Rinse 2. And you're going to want to pour the rinse water off to the side so it doesn't interfere with the sample you're eventually going to collect. And this is the final rinse that we take, and we pour it off to the side again. And now we're ready to collect our sample. So now we're going to collect our chloride sample in an amber bottle. The reason we use an amber bottle is that we want to stop light from penetrating the sample. And after we collect the sample, we also want to keep the sample cold. And the reason we do that is we just want to slow down any biological activity in the sample, so the sample stays as close to when we originally took it from the lake as possible. So I'm going to take my bottle here. You're going to want to make sure that you don't get any surface scums in the bottle. So one of the ways we can do that is if there is a surface scum, you can gently push it to the side. But we also want to invert our bottle like this so it enters the water and avoids that surface scum when it goes in. And then once you get it under the surface, you're going to tip it right side up and collect your sample like such. And one of the other things we want to do with the sample is we want to make sure that there's no air bubbles in the sample. The easiest way to do that is to take your cap, dip it in, fill it with water, and then gently pour the water so you can see the surface tension right on top of that bottle. And then you just put the cap on gently and close it. If you have a little air bubble in there for what we're collecting today, it's probably not going to be a big deal, but in general, we try to avoid collecting air bubbles.
Okay, so now you have successfully collected your water sample and we're ready to wrap up. So at this point, you want to make sure that you have filled out all of the different data fields on your data sheet, that everything is labeled correctly, that you have packed all of your equipment back into the cooler, checked the site to make sure nothing is left, and that's it. You're ready to go. Thank you so much for watching our training today. The next one is going to be on data management and data entry, where we'll walk you through how exactly to put your data into the database and get your sample in for analysis.
Also, you want to refrigerate your sample until you can get it to a place where they can ship it back to us or we can pick it up for analysis. We just want to thank everyone for their effort and their time to help volunteer for this project. project. This is really important data to be collected for the state and how we manage our natural resources. And so we thank you for your time. We could not do it without you, and we greatly appreciate you.
Happy
Happy sampling! Woo!